Hello, today we're going to start working with application problems with solving quadratics. Yesterday we worked on solve by factoring. So we're going to go back and kind of review how we can find a missing side length by factoring the area. And then we're going to transition into solving to find missing side lengths. Here it asks to find the length of the rectangle. Okay, and if you notice inside the rectangle we're given the area, and on the outside we are given one of our side lengths. So we're missing the length. We are given a trinomial, quadratic trinomial, so we will need to use our x box method. Our trinomial is x squared plus 5x plus 6. Step 1, always check for a GCF. There's no GCF. So step 2, identify your A, your B, and your C values. A is 1, B is 5, C is 6. So in your X table, remember you're going to multiply A times C, so 1 times 6 is 6, and your B value goes on the bottom. We're looking for the factor pair of 6 that has a sum of 5, and that factor pair is going to be 2 and 3. Okay, we're going to continue to factor using our box method. So remember, you're always going to keep your x squared, and you're always going to keep your constant, your 6. And the two side numbers we found in our x table, those are your x's. So we have a 2x and a 3x. Okay, in our first column, our GCF is x. Our second column, our GCF is 2. On the top row, our GCF is x, and on the bottom row, our GCF is 3. So if we pull our binomials out, our binomials are x plus 3 times x plus 2. Look back at the diagram. Notice we were given the side length x plus 2, so we know this side, the missing side, is x plus 3. Okay, in example 2, we are asked to find the length of the side of the square. So we know a square is going to have equal sides. So what that means is whatever this side equals, this side should also equal. So we're giving the area, and notice the area is in the form of a quadratic trinomial. And I'm going to recopy that. We have x squared minus 4x plus 4. Again, check for a GCF. There's no GCF. So we're ready to identify. A is your coefficient of x squared, so 1. B is your coefficient of x, negative 4. And C is your constant, positive 4. Okay, in our x table, remember we're multiplying A times C, so 1 times 4 is positive 4. And our B value is negative 4. We are trying to find a factor pair that when we multiply gives us positive 4, and when we add we get a sum of negative 4. And let's see, we could use negative 2 and negative 2. Negative 2 times negative 2 equals positive 4. Negative 2 plus negative 2 equals negative 4. Okay, now we're ready to box it. So again, transfer down your x squared and your positive 4. The two side numbers are going to become your x's. Make sure not to forget the x. Okay, in our top column, GCF of x. Remember, we factor out the leading sign, so we need to factor out a negative, and 2 and 4 are both divisible by 2. In our top row, our GCF is x. And our bottom row, our GCF is negative 2. So our two binomials are x minus 2 times x minus 2, or we can simplify this to x minus 2 squared. So a side length of the square is x minus 2. Okay, example 3 is going to really take us into the application where we use the solving. The first two examples we were just reviewing factoring. Now we're going to apply the solving. So if you look at number 3 with me, it says the length of a rectangle is 4 times its width. The area is 36 meters squared. Find the dimensions. So we've worked with problems similar to this when we wrote linear equations, but that dealt with perimeter. Now we're talking about area. Remember that when we're looking to define our variables, you want to think about, are we comparing the length to the width, or are we comparing the width to the length? I always tell my students to look for the word that's at the end of the sentence next to the period. That's usually what we're comparing to. So the length of a rectangle is 4 times its width. So we would need to define the width first. And I'm going to use the variable w. So now we know the length is 4 times the width, and we're using w to represent the width, so the length can be represented as 4w. Now we've talked about area of rectangles, but just to quickly review, the area of a rectangle is length times width. So we need to multiply the two dimensions, and they tell us in the problem that the area is 36 meters squared. So we are going to multiply w times 4w, and this should equal 36. When we multiply w times 4w, remember we have the same base, so we add our exponents, so w times 4w becomes 4w squared equals 36. Now yesterday when we started solving, we talked about standard form of a quadratic equation. We always want the equation to equal 0. So notice right now our equation equals 36. So to get this into standard form, we're going to subtract 36 on both sides, and we can't combine because those are not like terms, but we can just write it out in standard form. So 4w squared minus 36, 36 minus 36 equals 0. And now we have to start using that flow chart to kind of think through our process here. So again, when we factor, step 1, and let me just go ahead and transfer the equation. It says write the equation using the area formula. So our equation is 4w squared minus 36 equals 0. And I kind of skipped a step. Our width was w, our length was 4w, and they told us in the problem the area equals 36. Okay, step 4, write the standard form. So again, I've already done that. I kind of jumped ahead. Sorry about that. So we'll just transfer this down. 4w squared minus 36 equals 0. And now we're going to solve. So step 1, guys, is there a GCF? And as I look at my numbers, 4 and 36, I always test to see is my larger number divisible by my smaller number. And 36 is divisible by 4, so I'm going to factor my GCF of 4 out. So I'm just going to make a note that we have a GCF equal to 4. We're factoring out the 4. That's going to leave us with w squared. 36 divided by 4 is 9. And we're still setting this equal to 0. Okay, the last type of factoring we learned was difference of two perfect squares. And if you notice, we do have our difference, and w squared and 9 are both perfect squares. So again, just keep your 4. Go ahead and create your two binomials, set them equal to 0. We know that when we have this special case, difference of squares, one binomial will be negative, one binomial will be positive. And then to find the terms that go in our binomials, we just take the square roots. So the square root of w squared is w, and the square root of 9 is 3. Now when you're solving, you only solve using the expressions that contain variables. So notice this 4 does not have a variable, and 4 will never equal 0. So there's no solving to do with our 4. So we're saying that the product of 4 times w minus 3 times w plus 3 equals 0. So what that means is either our w minus 3 has to equal 0, or our w plus 3 needs to equal 0. So we're going to go ahead and solve for w. So in order to solve for w in our first equation, the inverse operation of subtraction is to add 3. So that's going to give us w equals 3. And in our second equation, we are going to subtract 3 on both sides. And we end up getting w equals negative 3. Now step 5 says eliminate the extraneous solution. Remember guys, when we measure a length or a width cannot be negative. So in this case, our extraneous solution is the w equals negative 3. So go ahead and just cross that solution out. So that means our width equals 3, and we still need to find our length. So this is why defining the variable is so important. If we scroll back up, we'll notice that the length equals 4 times the width. We now know our width is 3, so 4 times 3, the length equals 12. Thank you, and you have solved your first application problems with quadratics.